Hello and welcome to my calculus guide on integrals. Um, I recommend you watch these videos after you've taken the 5.1, 5.5 quiz, which covers LRAM, RRAM, NRAM, TRAM, and Simpson's method of approximation. I feel like if you've taken that quiz and you should have a good understanding of what this integral chapter is going to be about, and these videos I'm doing are going to cover in the textbook chapters 5.2, 5.3, 5.4, 6.2, and 6.3 in case you just want to follow along. So from the 5.1, 5.5 approximation units, you should know that the integral is just basically the area of a function to the x-axis. So, an example here, the area from this point to this point of this function is the area to the x-axis, but it doesn't always have to be positive. An example here, the area from this point to this point of this negative function will be negative. And since we have binded the integral to certain points, this a and this b, we call this a definite integral. And we write the definite integral like this. The integral, this is the integral sign, of a from a to b of f of x dx. Oh, sorry. The integral from a to b of f of x dx. And I drew an arrow here because this dx, the variable of integration, is very important. Without it, you can't take the integral and you'll lose points on everything you do related to calculus integration. So don't forget. So these are the bounds. Like as you can see here, the higher one goes on top and the lower one the bottom. It's pretty self-explanatory. And this is a function, of course. So along with integrals, definite integrals, there are some rules that you should know so that you can apply it to any function you're trying to find the definite integral of. And the first rule is that the integral from b to a of f of x dx, that means if you find the area in the reverse order and go like that, or like in this example like that, is the exact same as a negative integral from what you would do normally, like this. So just put concrete numbers here. That's saying if I took the integral from 5 to 3 of x squared dx, that equals the negative integral of 3 to 5 of x squared dx. So this rule is pretty simple, and it shouldn't be that hard to remember. It makes sense too if you think about it. The next rule is right here. The integral from a to a of f of x dx is equal to 0. So just to put more concrete numbers again, the integral from 1 to 1 of f of x dx equals 0. And this makes sense too because the integral is this area, and your area, the width of the area isn't changing, it's 0. So anything times 0 equals 0. So there's nothing too surprising about that rule. The next rule is kind of like the constant multiple rule of a derivative. It's that, hang on, let me try to fix the camera. Sorry about that. The integral of from a to b of k being any constant times the function f of x dx is equal to k times the integral from a to b of f of x dx. And just to give another example, the integral from say 0 to 1 of 2x squared dx equals the 2 times the integral from 0 to 1 of x squared dx. Okay, so next we have the sort of the sum and difference rule of derivatives in integral form. So this is saying that the integral from a to b of f of x plus or minus g of x, doesn't really matter, dx equals the integral from a to b of f of x dx, sorry, plus or minus the integral from a of b of g of x dx. So if you have the integral from 0 to 2 of x squared plus 5x dx, that is the integral from 0 to 2 of x squared dx plus the integral from 0 to 2 of 5x dx. Now, just to point this out, when you're say showing your work in a simple derivative problem, integral problem like this, did I say? Never mind. You don't really have to show this step that often, but I think it's a good idea to just know and recognize it. And also, we have this step right here, the integral from a to b of f of x dx plus the integral from b to c of f of x dx is equal to the integral from a to c of f of x dx. So if you have something like this, this is a, this is b, and this is c, the integral from a to b, that's this, plus the integral from b to c, that's this, is equal to the integral from a to c. That makes sense. So, you know, a lot of these derivative integral rules that I've stated right now aren't really too difficult to remember, and I believe it's kind of common sense. So hopefully that helps you understand definite integrals and some of their properties.